Hello, everyone. Welcome back. Today, we're going to talk about solving systems of linear equations by elimination. The idea here is we need to add or subtract the two equations in order to eliminate a variable. In this case, notice that over here we have plus y, and over here we also have plus y, right? And we also know that y minus y is going to eliminate y. Y minus y is 0. Any number subtracting itself gives us 0. So therefore, we can subtract the first equation from the second, or second from the first. Either way will eliminate the variable. So if we do that, we get x minus negative 3x, which recall that that's going to be 4x, because minus negative is actually plus. Y minus y is 0. And negative 2 minus 6 is negative 8. So we got a new very simple equation, which is 4x equals negative 8. Now, if we divide both sides by 4, we get x is equal to negative 2. Okay, now we're going to solve for y. So we know from the first equation, we can use either of the equations, but I'm going to use the first one. But we know from the first equation that x plus y equals negative 2. I'm just copying this from the original question. We know now that x is negative 2, so that means that negative 2 plus y equals negative 2. And so that means y must be equal to 0. So therefore, the solution to the system is that x is negative 2 and y is 0. That's our solution. Now, in some of these kinds of cases, there may be infinite solutions or no solutions. We'll get to those later. But in general, there's going to be exactly one solution in the vast majority of cases when we are solving a system of linear equations. The other cases would be considered special cases because they don't happen very often. Okay, let's do another example. Example 2. X plus 4y equals 22. 3x plus 2y is 5. So you might notice that, hey, we don't really have anything we could add or subtract that would actually eliminate a variable. I could add these equations or I could subtract them, but neither of those things will actually eliminate a variable. So what I'm going to do is I'm going to multiply one of these equations by a scalar in order to be able to use elimination. So something I'm noticing about the y's is that 4y is double what 2y is. So if I multiply this entire equation by 2, I can get a new equation that is an equivalent equation, and then I'll be able to eliminate y. So let's do that. And it's not necessarily by 2 we would have to multiply by. We can multiply by anything you want. However, keep in mind that in order to be able to eliminate, we need to make sure that the number we're multiplying by actually will allow us to do so. It's not that we'd get something incorrect if we didn't. We just wouldn't actually get further into solving this. So 3x times 2 is 6x. 2y times 2 is 4x. And 5 times 2 is 10. So there's my new equation. The other equation I'm just going to copy down. Sometimes, in certain cases, we may have to multiply both the equations to get the least common multiple in terms of our coefficients of either x or y. In this case, we did not, right? Even had we decided to eliminate x, in that case, we would have just multiplied the first equation by 3 and left the second equation the way it is. So even then, we only would have needed to do 1. So sometimes we don't really have to do both. Okay, now I'm going to subtract. So x minus 6x is negative 5x. I put x, my apologies. These should both be y. Sorry about that. There we go. Okay, 4y minus 4y is 0. That variable got eliminated. And then 22 minus 10 is 12. So therefore, x is equal to negative 12 over 5. Now, I know we got a fraction here. That is okay. Getting a fraction does not mean you got it wrong. Okay, next I'm going to plug this equation, x equals negative 12 over 5, back into one of my original ones, doesn't matter which, and solve for y. So I'll just plug it into the first one. Negative 12 over 5, which is x, plus 4y equals to 22. That means 4y is equal to 22 plus 12 over 5, if we add 12 over 5 to both sides. Then I'm going to get these denominators to be the same to add them. So 22 times 5 is 110. Therefore, 22 is the same as 110 over 5. And then, of course, we have our plus 12 over 5. That means 4y is going to be 122 over 5. And then if we divide by 4, we get y equals 122 over 20. And that can be reduced. Yeah, that can be reduced to 61 over 10, or 6.1 if you prefer decimals. Okay, so therefore, the final answer is negative 12 over 5, 61 over 10. Right? And so this is an example where elimination worked, where graphing would not have necessarily worked. We would have kind of been able to see a ballpark. I don't think we would have been able to guess these exact numbers had we drawn these on a graph. But essentially, this is the intersection point. If we were to draw these two lines on a graph, they would intersect at the point negative 12 over 5, 61, 10. All right. Good work, everyone, and we'll see you for the next one.